Hi everybody. Today I am going to discuss about three-phase bridge inverter, which is also known as voltage source inverter. In short form, in other words, we call it as VSI. The three-phase voltage source inverter generally operates in two modes of operation. It is 180 degree mode of operation and the other one is 120 degree mode of operation. Today we are going to discuss about the voltage source inverter which operates in 180 degree mode of operation. So an inverter is one which has a DC supply which is represented as Vs, and output load is an AC load which is ABC, balanced load, and we have three arms A, B, C, or 1, 2 and 3. Each arm has upper arm and lower arm thyristors. To understand this in a much better way, we can understand that A, B and C. A phase is displaced from B by 120 degree and B is displaced from C by another 120 degree. So when we say it is A is starting at origin 0 degrees, B will start at 120 degree and C will start at 240 degrees. Same way, minus A is the dotted line represented in the phasor diagram, which will be exactly after 180 degrees of it. And so minus B is 180 degree opposite to B and C is opposite to minus C by another 180 degree from it. Okay, so from the circuit diagram, it is understood that each upper arm thyristors are representing the positive phase and each lower arm thyristor represents the negative phase of the three phases. So switch 1, 3 and 5 represents the upper arm thyristors, which is the positive phase sequence, and 4, 6 and 2 represents the negative phase of the lower arm thyristors. Okay, so based on the vector diagram or phase difference between A, B, C, assuming that T1 is triggered right now, T3 will be triggered exactly after 120 degree and T5 will be starting or it will conduct only after 240 degrees. Same way, we can easily understand that if switch 1 represents the positive phase sequence of the upper arm thyristor, switch 4 represents the negative phase sequence of the first arm thyristor, which means first arm. So when this is starting at 0 degree, switch 4 will start at 180 degree exactly up. Fine. Likewise, when 3 is starting at 120 degree, which is the second arm, upper arm thyristor, and the second lower arm thyristor is nothing but T6, which will exactly conduct after 180 degree from this, which is the 300 degrees. Same way, when T5 is starting at 240 degree, and this is the positive sequence of the C phase, and the negative phase sequence of the C phase is represented by the T2 thyristor, which will start at 420 degrees. You may wonder why it is coming, because if at each and every 360 degree it is repeating, so we just go backward to minus 360 degree, it is exactly here. That is how it's starting here. So all this came by that way. So switch 1 starts at 0 degree, conducts for 180 degree, and again at 360 degree it starts conducting and ends up at 540 degree. Same way, switch 3 starts conducting at 120 degree, it conducts for 180 degree, so it is working or triggered on until 300 degrees. Then again after 180 degree it starts conducting and it's again conducting for 180 degree. This holds the same for all the thyristors. So the basic understanding is A, B and C, minus A, minus B and minus C switches or the phases. So this is how the phase sequence goes, or the thyristors are being triggered on to create the ABC phases or three phases. So each thyristor conducts for 180 degree and turned off for another 180 degree. Again it is turned on for another 180 degree. This is how the sequence goes. Let us understand from 0 to 60 degree. We are cutting or stepping or gripping everything into 6 steps. 0 to 360 degree are just classified from 0 to 60, 60 to 120, 120 to 180, and this is how it goes, which means we have 6 steps. So the first step is from 0 to 60 degree. Let us check which thyristors or which switches are turned on in the first step, nothing but for the duration of 0 to 60 degree. So for the step 1, for the duration of 0 to 60 degree, switch 1 is conducting, switch 2, switch 3, switch 4 is not conducting, whereas switch 5 and switch 6 is conducting. So this is a simple understanding that we can easily remember 3 thyristors are conducting for one step or one particular sequence, and the thyristors that is conducting for step 1 is 1, 5 and 6. Likewise, let us check for the next step. For the step 2, again 60 to 120 degree, let us check which thyristors are being turned on. It is again for the step 2, it is switch 1, switch 2 and then switch 6. For the step 3, for 120 degree to 180 degrees, it is again switch 1, 2 and 3. Remaining 3 thyristors are off. Now at step 4, which is from 180 to 240 degrees, switch 1 is off. Next, the turned on thyristors are 2, 3 and 4. Other 3 thyristors are off. For the step 5, from 240 to 300 degrees, it is 3, 4 and 5. Remaining 3 thyristors are off. Last step is step 6, 300 to 360 degrees. It is the switch 4, 5 and 6 are turned on and the remaining thyristors are off. So for each and every step, 3 thyristors are on and 3 thyristors are off. And this is how the sequence goes. So here I have represented the sequential operation of the conduction of thyristors or the thyristors that is triggered on. From the gate signals for each thyristors, it is understood that for the step 1, 5, 6 and 1 switches are turned on. For the next second step, it is 6, 1, 2. And for the third step, it is 1, 2 and 3 switches are turned on. For the fourth step, it is switch 2, 3 and 4 turned on. For the step 5, switches 3, 4 and 5 are conducting. Likewise, for the last step, step 6, switches 4, 5 and 6 are conducting. So let us start with the first step, in which we'll have the 5, 6 and 1 switches are being turned on, or the thyristors which is encircled represents the one which is triggered on, or the gate pulse is given to the 3 thyristors. Remaining 3 thyristors which is not been circled represents that they are not conducting. So as we see in the sequence of steps, for the second step it is 6, 1 and 2 thyristors are conducting, and for the step 3, thyristors 1, 2 and 3 are conducting, and for the step 4, it is 2, 3, 4 thyristors are turned on. In step 5, the thyristors 3, 4, 5 are triggered, and in the last step, step 6, thyristors 4, 5 and 6 are triggered on. Remaining thyristors are off. Let us start with the step 1, which means from 0 to 60 degrees. As we have seen in the sequence of steps and also in the previous circuits, the encircled one represents the thyristors that is turned on. So from the understanding of this circuit diagram, it is the switch 1, 5 and 6 are turned on. With this, we have to calculate, or we have to analyze what is the voltage across each and every phases and the line voltages. For an easy understanding, let us assume the load, the three-phase load, is a balanced load which is represented as Z. So all the three phases have a balanced load Z, Z and Z. Let us have an equivalent circuit from this circuit diagram, which is represented by this way. This represents that T1, this Z represents the T5 and this represents the T6. As I told before in the previous slide, the upper arm thyristors represents the positive phase sequence and the lower arm thyristors represents the negative phase sequence. Here, since T1 represents the positive phase sequence of A, here Z is drawn here, and likewise T5 represents the positive phase sequence of C, C is drawn here and Z is represented here. And 6 is conducting, switch 6 is conducting, which is representing the negative phase of the B phase, and that is why from neutral to B, the Z or the load is represented here. So the equivalent circuit represents the input voltage source or DC supply Vs. Based on the sequential or the switch that is conducting, the load is represented. As per the circuit diagram, in step 1, the A phase, positive C phase is conducting and negative B phase is conducting. That is why the load is represented by this way. So the input or the load current is nothing but I1. Voltage source is Vs. So to understand or to observe the voltage across each and every particular phases, it is easy for us to calculate by Ohm's law, which is nothing but I1 equal to V by R. Here R is nothing but the total impedance. Here it is Z, Z, and it is each R balance, each is representing the balanced load. When you take it for a combined way, it is Z by 2 represented for both A and C, and the lower one is nothing but Z. So the current I1 is nothing but equivalent to 2 by 3 Vs by Z. And the voltage across each particular load or phase is for A to neutral, it is Vs by 3, and C to neutral, which is 0 or O, represented as O, is Vs by 3. Likewise, the voltage between across 0 to or neutral to B is 2 Vs by 3. This is obtained by this. As we have got the I1 or the load voltage, load current, we can easily get the phase voltages, which is nothing but VA0, VB0 and VC0. Both VA0 and VC0 are same because it is between this node to this node. So we have written as VA0 equal to VC0 equal to, which is nothing but again based on Ohm's law, V equal to IR. So VA0 and VC0 is equivalent to load current, which is I1, into the impedance, total impedance, which is Z by 2. So at last we got VA0 and VC0 as Vs by 3. And it is between the neutral to the B phase, which is nothing but V0B, is again equivalent to I into Z, which is equivalent to V0B is 2 by 3 Vs. So recollecting the phase voltages, VA0 and VC0 equal to Vs by 3, we obtained V0B, which is exactly opposite to VB0. So V0B, what we have obtained was 2 by 3 Vs. So when we rewrite as VB0, it becomes minus 2 by 3 Vs. So these are the phase voltages obtained, VA0, VB0 and VC0. Likewise, we can obtain or we can derive the line voltage. The line voltage VAB is equivalent to VA naught plus VB naught, V naught B, or VA naught minus VB naught. We can take VA naught minus VB naught because we have written as VA naught, VB naught and VC naught. So we'll follow the same for the remaining two line voltages. So VAB, line voltage VAB, line to line voltage VAB is represented as VA naught minus VB naught. VBC is equivalent to VB naught minus VC naught, and VCA is equivalent to VC naught minus VA naught. Since we have all these voltages, phase voltages, we are just substituting it here and we are obtaining the line voltages. From this, we obtain that line voltages VAB equal to VS, VBC equal to minus VS, and VCA equal to 0. All these represents the phase and line voltages of the load for the step 1, which is between 0 to 60 degree. So we have to continue for the remaining 4 steps by this way. We have to find which switch has been triggered on for the each and every step. Then we have to draw the equivalent circuit, find the load current, then find the phase voltages and line voltages. Upon doing all the 6 steps, drawing the equivalent circuit and finding the phase and line voltages for all the 6 steps, it has been tabulated by this way such that this represents the steps, 6 steps. Step 1, 0 to 60 degree. Step 2, 60 to 120 degrees. And step 3, 120 to 180 degree. Step 4, 180 to 240 degrees. And step 5, 240 to 300 degrees. And last step 6 is 300 to 360 degrees. For each and every step, I have represented the phase voltages VA0, VB0 and VC0, and the line voltages VAB, VBC and VCA. So the 2 steps I have derived in this video itself. So it is the phase voltages for the first step is Vs by 3 minus 2 Vs by 3 and Vs by 3. And the line voltages for the step 1 was Vs minus Vs and 0. Likewise, I have tabulated by deriving for the remaining 4 steps, and I have given the phase voltages and line voltages for all the steps. With this, we are going to draw the step across the load, nothing but phase voltages and the line voltages. With the table, it is understood that from 0 to 60 degree, the phase voltages are VA naught equal to Vs by 3 and VB naught is equal to minus 2 Vs by 3 and VC naught equal to Vs by 3. I'm just showing the phase voltage in this slide and then I'll show the line voltage. So for the each and every step based on the tabular column, we are just drawing the step. So I've classified the x and y axis as degrees here, 60, 120, 180. For a easy understanding, I've classified as 60 degrees for each and every step, representing each and every step. So the phase voltages go by this way. For step 1 it is Vs by 3, step 2 it is 2 Vs by 3, and step 3 it is Vs by 3, and step 4 it is minus Vs by 3, and step 5 it is minus 2 Vs by 3, and step 6 it is minus Vs by 3. Then it goes to 0 again, it attains the Vs by 3 for the next step. So it is just the sequence. This is one cycle and the cycle repeats. This is the same for the VB0 and VC0. We have seen the phase voltages. Let us check and observe the line voltages also. From the tabular column, we have observed that line voltages are VAB, VBC, VCA, and for step 1, 0 to 60 degree, VAB was Vs, and VBC is minus Vs, and VCA is equal to 0. So the next step is 60 to 120 degrees. Step 2, VAB is equal to Vs again, VBC is 0 and VCA is minus Vs. Let us just observe VAB right now. So for the step 1 it is Vs, and step 2 it is Vs, step 3 it is 0, step 4 and 5 it is minus Vs, and step 6 it is 0. So this is one complete cycle, after which it is just the repetition. Same happens for VBC and VCA.